Okay, this screencast is to review exam 1. Okay, on the first problem, I'm happy to say everybody got this one right. Indeed, if you apply an impulse function, you get out the impulse response. Okay, so congratulations to everybody who got that right, which is all of you. Okay, next, we need to model a particular signal with a complex exponential. So something of the form x e to the st. What is x and what is s? Okay, so I think most people got this right, that you take s equals 0, e to the 0 is 1, and so you just get a constant in that particular case. All right, we had a few problems with the cosine term. If you look at the cosine term, you can use Euler's formula and model that with a complex exponential. You need s to be j6. Some people forgot the j. Okay, and then the amplitude on that would be a 3. Okay, and then probably the most missed part was how do you handle this phase shift with the cosine? Well, you can look at properties of complex exponentials and make the conclusion that you would take care of that by adding this complex exponential at the front. Okay, so e to the j pi over 3 would take care of the phase shift term, and you still have to have the frequency term e to the j8. Okay, so one way of thinking of that is 2 e to the j pi over 3 times e to the j8 is the same thing, times t, right? Because it's e to the st. All right, this would be the same thing as 2 e to the j 8t plus pi over 3, which in terms of Euler's formula is 2 cosine 8t plus pi over 3 plus 2j sine of 8t plus pi over 3. And then, of course, we take the real part to model the to model the cosine. So that's why you need this e to the j pi 3 out in front. Okay? And then the last one, this is just a real exponential, so this s term would be minus 3 and the x term would be 2. Okay, so that's problem number 2. Okay, problem number 3, most people made good progress on part A. Okay, so what we realize here is this is a inverse Laplace transform with complex roots. Okay, so you can use the completing the square trick, and you would get s plus 3 squared plus 4 squared. And then on the top, it still stays the same, 3s plus 7. Okay, so we're trying to make this look like s plus b over, a s plus a squared plus b squared. That's the cosine term. And then the sine term would be the b over s plus a squared plus b squared. That gives me sine. Okay, so I'm trying to make it look like that. Okay, so I start with the 3s plus 3. And when I make this, this term s plus 3, when I put that there so it will fit this form, when I distribute the 3 across, that'd be 3s plus 9, but this should be 3s plus 7, so I need to subtract 2. Okay. All right. And once I have that, I know that this term needs a 4. Okay, on the top. So I put the 4 there and then I divide by 4 so that effectively I'm multiplying by 1. Okay, so you see that's got the 4 there, and The constant out front would be 2 over 4, so that's minus 1/2. And so the bottom line is that we do this inverse and we get y of t is 3e to the minus 3t cosine 4t minus 1/2 e to the minus 3t sine of 4t. Okay, so that's that term. All right. The next problem is an inverse Laplace transform problem, and you needed to recognize that this e to the minus st term suggests the time shift property. Okay, so the way I work this is I took away the e to the minus st term and called the new signal x tilde of s. From there I can find x of t by doing a partial fraction expansion. Okay, so you quickly do that and you can find a would be, you plug in, you cover up the s and you plug in 0 for what's left, so you get a equal 1. And then b would be, you plug in s equal minus 1 and cover up the s plus 1 term, and so b is equal to minus 1. And so we know that x tilde of t is 1 minus e to the minus t. Okay, now here's the catch. With this kind of problem, the time shift problem, we talked about this a little bit, you really need to start including the unit step function, because that's what makes the signal right-sided. If we just assume it's right-sided, we can get away with not writing the unit step function. But if I'm going to apply a time shift, I really need to add the unit step function in there. So now I know that since x tilde of t has the Laplace transform 1 over s plus 1, then that means x of t is going to be x tilde of t minus 1. That's the time shift property for e to the minus 1s. The time shift is negative 1. Okay? So if that's the case, then x of t is going to be 1 minus e to the minus t minus 1 u of t minus 1. Okay, so that's the proper application of the time shift for that